Hello everyone. So in this video, we will be presenting about gas chromatography. Me and my teammates will explain the theory, methodology, results, and discussion of our experiment. So this is me. I am Mr. Valan, and my teammates Muhammad Nabil, Hadi Amizan, and Muhammad Uzairi. So we'll start with an introduction. So what is gas chromatography? Gas chromatography, or GC, is an analytical technique used to separate volatile compounds. The separation is based on differences in boiling point and how each compound interacts with the stationary phase. In gas chromatography, an inert gas such as helium or nitrogen acts as the mobile phase, while the stationary phase is inside the column. Gas chromatography is commonly used to analyze organic and volatile compounds. Moving on to the principle of gas chromatography. So, in gas chromatography, the sample is first injected and vaporized. The carrier gas then transports the sample through the column. As the sample moves through the column, the components separate due to differences in boiling point and affinity towards the stationary phase. The detector then converts this separation into chromatogram.
Hello, this is the objective. First, to determine the retention times Tr of N-butanol and propanol. Second, to identify the components present in a standard mixture based on the Tr. To identify the components present in an unknown sample. The last one, to determine the effect of temperature on Tr and Rs. So this is a figure about the schematic diagram of a gas chromatography. So, as you can see, uh, this is a function of GC components. So all of this is the GC components. The first one we have a carrier gas. Its work as carrier to carry the sample through the column, flow controller to keep the gas flow stable during analysis, injection port, it heats and vaporizes the liquid sample, column where the separation of compound happens, oven, control the column temperature, detector FID, detects the component as they exit the column, and the last recorder or data system, it shows the chromatogram on the screen.
So here is the result for experiment 5. So this table shows the retention times obtained at different temperatures. At 70 degrees Celsius, the standard mixture produced two peaks at 2.645 and 5.874 minutes. Individual injections show that 2-propanol eluted earlier than N-butanol. As temperature increased to 100 and 140 degrees Celsius, the retention times become shorter. At 70 degrees Celsius, the standard mixture clearly shows two separate peaks, indicating successful separation. 2-propanol had a retention time of 2.701 minutes, while N-butanol had a longer retention time of 6.012 minutes. This difference is mainly due to their different boiling point.
Hello, my name is Muhammad Nabil bin Jasni, and now I will talk about discussion. The peaks in the standard mixture were identified by comparing them with the individual standards. The unknown sample peak near 2.7 to 3.0 minutes corresponds to 2-propanol. When the column temperature was increased, the retention times decreased because the compounds interacted less with the stationary phase. However, the peaks became closer together, showing reduced resolution. In conclusion, gas chromatography successfully separated 2-propanol and N-butanol. The unknown sample was identified as 2-propanol using retention time comparison. Increasing column temperature reduces retention time but also reduces resolution. This shows that temperature control is important for good GC separation and all objectives of the experiment were achieved.